Okay. Good morning, ladies and gentlemen. Good morning. Dear participants and organizers of the 13th Advanced Training course on land remote sensing with the focus on snow and glaciers. On behalf of the Rectorate, it is my pleasure to welcome you here at the University of Innsbruck. It is an honor for us to host this training course organized by the ESA, in particular by Espen Holden, Magdalena Fitzrig, okay, Irene Renis, in cooperation with NVO, especially Thomas Nagler and Helmut Roth, and the FFG, the Austrian Research Promotion Agency, especially Thomas Geist. Many thanks as well to all the lecturers and to the organizers for putting on such fascinating event, especially Philippe Lamboy from our BFÖ, the event management here at the University of Innsbruck, and also, of course, Irmgard Yuan from our research area, Mountain Regions. I'd also like to mention and to thank DG Josef Aschbacher, who graduated at the University of Innsbruck and holds a FD in natural science from our university, for his constant support. To be completely honest with you, I was actually asked to give this introduction quite last minute because of some changes on our end, but the more I read about this event, the more I saw the connection between my role here as Vice Rector of Digitalization and Sustainability and your program this week. In an ever-changing world, it is all the more important to be able to monitor Earth, snow, and glaciers, especially, to do multi-source data analysis and so on. Even today, we meet after and during days of weather warnings and floods in Austria, demonstrating how important your work is. The University of Innsbruck was founded over 350 years ago and is the most important research and educational institution in Western Austria today, with about 28,000 students and about 5,500 employees. We recently celebrated our 35th anniversary with the motto, "We build bridges into the future." And this is all the more true here, training the next generation of Earth observation scientists and experts. I hope you enjoy this event and the whole program this week and wish you a pleasant stay here in Innsbruck. Thank you. I'd like to hand over.
Thank you very much. So I this microphone as well. Can you hear me now, or?
Yes.
Right, okay. So welcome everybody to this training course, which is you can see that the 13th edition of our advanced land remote sensing training course that we have been doing for many years. Very happy to see lots of young scientists in the room. Maybe not all are teenagers, but on the average it's a quite young audience, and that's what we are really we need to train the young scientists for the next generation, so that we will have scientists that can be all either join ESA or do activities that we are doing in collaboration with universities, companies. Okay, so it doesn't work very well, I see. So I have a little presentation now to introduce you to the course. I'll just get into it immediately. So as I said, we have done this 12 times before in different countries, on different subjects. At the start, we did a general course on all related to land remote sensing. In the last years, we have chosen one subject or one thematics for each year. So this year on snow and glaciers, but we have done other themes like hydrology or agriculture in the previous years. So, as I already mentioned, what we want to do with this training course while we're doing it is we would like to train the next generation of scientists and professionals to better use remote sensing for monitoring of snow and glaciers. We will explain both the theoretical principles, processing algorithms, and also data products and how to use them. We will also introduce some tools and methods for how to exploit the data. And of course, the sentinels will be in the focus during the whole course. Then with this, we hope to also to stimulate and support the use of data both for science applications, so for use by scientists as yourself, but also for operational use. So we also show some operational applications, and some of you are involved in that as well already. So that is really what we want to do with this training course. So who are behind the course? It was already mentioned by Vice Rector here. Of course, now I put ESA at first. That's a privilege of me having made this presentation, and I will put myself first also, of course. But Magdalena and Irene, they have done 10 times more work on this than myself. Then the University of Innsbruck, Wolfgang Gurgiser, Philippe Lamboy, and Irmgard Jun. And here also, of course, Irmgard has done 10 times more than the others. And then we have Thomas Geist from FFG, who was, I think we had the first real discussion where we had, when we started thinking about this year's course, where should we do it, on what theme? First we said, okay, maybe we should do it on snow and glaciers this time. And then I met with Thomas Geist at a meeting in Esrin and mentioned this idea to see if it was supported by the ESA delegation, since Thomas is part of that. And he was very enthusiastic and supportive for this immediately. So, and us also afterwards found some money to sponsor also the event. So thank you very much. And then Thomas Nagli and Helmut Roth from NVO. They have also been key in preparation of this course from the start, both preparing really the content of the course, and also they will be teachers during the course, and they help us also find other teachers. So that's other names. And then we, of course, have all the nice teachers. I won't go through all the names, but I think we already have Thomas Nagler and Helmut Roth in the room. And also maybe, Fabrizio, where are you, Fabrizio? Maybe you can show yourself. You're there also. Frank Paul, I think I saw also. Yes, so at least some of the teachers, I don't know if you have somebody else there, but we have really top scientists from Europe working in this domain. Then we have you, the participants. So as I said, okay, you're young on the average, and you come from quite a few countries. So we have counted, so you're 50 in all, and we have counted 18 different countries as countries of the institutions where you are affiliated. So we have mostly from Europe, and the few countries also outside, and both outside European Union as well. Then we also have looked at the nationalities, and there we have even more. We have 22 different nationalities. What I should have said also, that Austria is top in terms of institutions, maybe a bit natural since you are close. And then Germany, of course, Germany and Italy as neighboring, big neighboring countries. And nationality, it's German and Italian on the top. So what are we going to do during this training course? If you see on the left side here, we have this introduction during the whole morning today with more general presentations. Then we have all these yellow parts here, which are theoretical lectures. And then we have the orange, which are the practical exercises. And then we have a few social events. So that's what we're going to do. Now I'll try to zoom in a little bit on if I can find the touch. So this morning, now just after me, I have to watch a bit clock. So we will have our Director General from ESA to do a welcome. That's the first time in our series of 13 training courses that we have our Director General. Then we will have a presentation from Thomas Geist about activities in Austria. I will talk a bit about what we're doing in our Science for Society program in ESA. And Anna Maria will talk to us about activities related to climate change and also Copernicus services. Then we will all go to do a group photo together and then have some coffee before we have a last mission this morning. We will have some presentations from our different mission scientists or mission managers in charge of different sentinels that are relevant for our training course. And then we will go to lunch. So that's this morning. And then I would just mention, if I can go down, yes. So we will have some introductory courses today, lectures. And then when we come to the exercises, then we will split up into 2 rooms. So on the floor above, because we will go into computer rooms with 20 computers in each room. So just remember that we have to split for all these different exercises. Then to mention that today at 6:30 we have a social event, an icebreaker, which will be just outside the room towards the entrance. Then tomorrow, is there something special? So we start with the lectures, exercises. So we have lunch. Okay, we have lunch break, a common lunch break today and tomorrow, 12:30 today and 13 tomorrow, and 12:30 today to 13 tomorrow. But then you must note that on the Thursday we will have a split lunch break, just so that you know that. So, sorry? A full screen. In presentation mode, it will just, in presentation it will be smaller. Yeah, that's why I'm doing it in this way, to make it big, but I can try to do it even bigger, but like this. So just that you're aware that not everybody can run for lunch at 13 on the Thursday. So I mentioned that we will have a social event today, the icebreaker, and then on the Wednesday we will have another one where we'll go to visit a glacier together. I think that would be very, very nice. I think the weather gods are with us also. And then also anything else I should mention of practical things? Yes, the Thursday event. We have the dinner directly after the field trip. And then on the Thursday, we have this session with lightning talks by yourself. So we said, okay, it's not mandatory, but we hope really that as many as possible of you will do this very short presentation, so we can get a little view into what each of you is interested in working on. So for this, kindly ask you to submit this presentation by this evening. And then we will go on the whole week until Friday. And just to say that on Friday, so the closing ceremony starts at 1:30, so we should close at 2 o'clock, and there is no lunch break. But we have checked that there are things that are open after 2 o'clock, so that at least you can get something to eat when we have finished. Okay. I don't think there was anything else important to say about the organization. So also to tell you that we will give you a certificate of attendance of the course, but for this you must participate to all lectures and practical classes. And of course that's what we are expecting anyway. Also, we are investing more than 1,000 euros per student for the training course. So of course we expect that people will attend all the lectures and the practicals. So we'll circulate the list during the week, every day during the week, and then we will give you the certificate during this closing ceremony that starts on 1:30 on Friday. We will also towards the end of the week, I think it's on Thursday afternoon or something, that we will provide you a link to a questionnaire. So we will ask you your feedback on the training course, on different aspects of the course, to see, so that we can understand what you were happy about or not, so we can take that into account for next year. And then also to tell you that after the training course, we will put all the material on our website, so you can find both the presentations in PDF format. You will have also videos recorded of all the lectures. So that in that way you can go back to things, or you can also, of course, share that with colleagues who could be interested and seeing this afterwards. So just, I think I already said all of this. To remember that everybody cannot go to the lunch at the same time on Thursday. And for the Wednesday trip, yes, be sure to bring some warm clothes and some hiking shoes. And do not forget to deliver this short presentation today for this lightning talks session on the Thursday. I think that was all. Then we have 5 minutes before our DG will connect, and I think that's what we wanted, to have a little bit to be sure that everything works beforehand. So let's just try and check if we have him online, so you can just discuss and get to know each other for a few minutes while we try to get this online. Thank you. Hello, Joseph. Are you with us?
Hello. So, good morning. Good morning, Joseph. We can hear you. I have problems, so I will checking. I think we have an echo here. Can you hear me? Can you see me?
Yes.
Good. So you tell me, Espen, is it you organizing it on your side? You have to tell me when you want me to start saying a couple of words. It seems that you're waiting for my start. So first of all, very happy to talk to you. You're sitting in the at my university where I used to study. I did my master's thesis and my PhD thesis on exactly that place. Probably some of you are sitting on the places I've been sitting myself. So really happy to welcome you. I'm unfortunately not with you in Innsbruck. I'm here in Paris. There's the World Space Business Week ongoing right now, and I have to give a talk in a couple of minutes, actually, just next door at the meeting. But let me give a couple of words from my side. So first of all, very, very happy to talk to you. Snow and ice, of course, are major domains at the University of Innsbruck, but also globally, which is of extreme importance. You all know it very well for climate change, for mass balance estimates, and many other domains that are related to it. And what you are doing in your meeting, in your conference, or in your training course, actually, is extremely important in terms of domains and topics that we are addressing globally. Let me put this a little bit in context. Of course, climate change has been a major topic for ESA and space in Europe. It is anchored in what I call the strategic document Agenda 2025, which I put on the table when I became Director General of ESA a bit more than 3 years ago. But we also have in ESA a dedicated climate office, which is hosted in Harwell in the UK. We are running a program to monitor and collect information for the global monitoring of essential climate variables. And we have a very, very strong involvement of ESA, either ESA directly or ESA scientists, ESA projects in the United Nations Framework Convention on Climate Change and the IPCC when the new reports are coming up and being updated. And of course, the Climate Change Service, which is one of the Copernicus services, is a major element as well, which we support, but also in the case of the Copernicus Climate Change Service, this is led by the European Union. So as you see, climate change and, of course, snow, ice, mass balances are an extremely important topic. And as ESA, I think it is fair to say, we have been really advancing this since the very early days of Earth observation, of remote sensing. The very first satellite of ESA on Earth observation, ERS-1, launched in 91, was focusing on parameters of climate, but also snow and ice in particular, followed by ERS-2, followed by Envisat, and of course the whole Copernicus program, which ESA is developing together with the European Commission, is having a major focus there. Some of you may have followed in the news that we have just launched Sentinel-2C, Sentinel-1C will follow very soon. The plan is to launch it on the Vega Vega C return to flight before the end of the year. It is really a symbol of European excellence and ambition, what we are putting together here. It is fair to say that Copernicus and the European Earth Observation Program built up by the European Space Agency is among the best in the world, if not the best in the world, and is providing reference measurements to many scientists in Europe, but also worldwide. Today, as you have probably seen in some publications of ESA, we are disseminating about 350 terabytes of data every single day to users worldwide, free of charge to everyone. And this is quite unique and is also the reason for the success of Copernicus. We will hear more about the current and the future Copernicus missions for snow and glacier monitoring in dedicated sessions later on. Certainly they will focus on Sentinel-1, Sentinel-2, Sentinel-3, Roselle, CHIME, LSTM, Crystal, and other missions. As you know, this is a whole portfolio of missions which we have designed for climate change, for climate monitoring, and especially with applications on snow and ice being such a sensible parameter of climate change, and therefore really deserving a number of instruments and satellites that we have been doing. So why is ESA organizing this course? Because ESA needs brilliant young people, brilliant young scientists with a very strong knowledge in Earth observation. We also want you to look at ESA as a possible future employer. You can join ESA. I myself joined ESA actually right from the University of Innsbruck as a young graduate trainee at the very bottom of the scale. And as you see now, I'm at the very top of the pyramid. But I'm just one out of many people in ESA. We have brilliant people, engineers, scientists that are working day and night to make space useful for citizens and for society, and addressing some of the miracles which space can answer and can provide. So this course will certainly help Europe to maintain and advance its position in the crucial field of space-based Earth observation. And as a last word, I really would like to send you my very best greetings here from Paris to Innsbruck. As I said, my heart is still there, and I'm still very happy every time I hear about the achievements that happen around the University of Innsbruck and the team there. My personal greetings to all of you who probably still remember my name from early days, and of course all the young people here in the training course to encourage you, go into space, go into ESA, and wish you a very successful course in the next couple of days. So thank you very much.
Thank you very much.
Thank you very much, and I log off from here, and it was really nice talking to you. Bye-bye.
Didn't work. Next presentation by Thomas Geist, who will talk to us about activities in Austria. Please, Thomas.
Yes, thank you very much. It's of course a little challenge to be right after the Director General, so but anyway, I try to do my best. So my name is Thomas Geist. I'm working for the Austrian Space Agency, and my field of responsibility is Earth observation. So if I talk about space in Austria, there's a bit of a bias, and it's well, always from the perspective of Earth observation, or most of it I want to tell you in the next 10 to 15 minutes. Within my responsibility, I'm also Austrian delegate to the Program Board for Earth Observation at the European Space Agency. And Yeah, and this means a lot of paperwork, to read a lot of documents, to be in meetings, to connect with industry in Austria, with the scientists in Austria, and on the other side, of course, with all the colleagues at the European Space Agency. But I will not start with a paperwork image. It's another image. It's almost 20 years old now, almost exactly 20 years. And what you can see here, that's a high-resolution digital elevation model. It's a visualization of it. It's a glacier in Tyrol in the southwest of Innsbruck. It's a Hintereisferner, one of the most or best investigated glaciers we have in Austria. And you can see the tongue of the glacier, the lower part of the tongue from the lower left corner to the center. That was part of my PhD work here at the University of Innsbruck 20 years ago. And it was about airborne laser scanning and how to use this technology, which at that time was a very new technology. Now it's quite established, to use it to find out what you can do in glaciology with these data and with this technology. Yes, that was 20 years ago, and I think if we were now 20 years in the past, then I would be very, very happy to sit on the other side of the table to be at this training course. I will continue with another sketch, and if you decide just to remember one slide of my presentation, to take home one slide of this presentation, then you should go for this one, because this summarizes, I would say, very good what Earth observation in Austria connects. So first of all, it's a satellite. So in Austria, there is a small but fine supplier industry for satellites. And for example, if you look to a satellite and you see the golden or silver foils, which is around the main parts of the satellite, the thermal insulation of the satellite, and many of these foils are manufactured in Austria. So that's one part of the satellite which is done here. Then, of course, we have a lot of application fields which we are interested in Austria. Many of them are related to land use, land cover, and changes of land use and land cover, with maybe a focus on agriculture and forestry, but also urban planning. Of course, it's the high mountains, snow, glaciers, sometimes connected with tourism. This is especially here in the western part, still a very important economic factor also. Then it's the natural hazards, and unfortunately it's very, very actual today with the flooding in the eastern part of Austria in the moment, but also in the surrounding countries, Poland and the Czech Republic in the moment. And of course, on the right side, you see the ESA logo. And that means that ESA is for us, and I will show numbers, I think, on the next slide, the most important partner if you talk about space. And of course, there is the world in the bottom of this sketch. The scientists and all the industry in Austria is not only focused on Austria, but of course goes outside, is connected, to other parts in the world, to other continents. So that's very important for Austria. Well, we have a space agency. In the beginning, I was introduced as working for FFG. So you see the acronym on the right, upper right corner. That's the biggest innovation agency we have in Austria. And the space agency is a small part of this bigger agency. And what we are doing is just on the right side of this slide, while we have a national program for research, development, and innovation for space. I will come with one or two slides later on to that. Then, as I said, we are the interface between the Austrian scientists, the Austrian industry, and the big European institutions like the European Space Agency, but also other European programs like the European Union Space Program or the programs of EUMETSAT, which is the organization who is operating the weather satellites in Europe. And that's on the bottom here. We support and implement education and awareness activities. And while one of those is this one here, this training course, we are very, very happy to have it here in Innsbruck. Okay, in the middle there is this pie chart, and you see the budget we have for space in Austria, the annual budget. That's more or less 100 million euro per year. That's quite stable over the last years. You can see different colors here. And the blue and the green color, that is European, are European programs. The green one, that's the European Union Space Program, and other programs like Horizon Europe, which is a framework program for research and innovation. And well, that's not, of course, not directly managed by us. That's paid via the European budget. But the blue one, that's the most important one. That's more of the half of our budget, and that's money we are giving to ESA, and of course hope to get it back in form of scientific contracts or of industry contracts. And to summarize this, if we talk about space in Austria, then we have to talk also about the partnership between Austria and ESA. That's really essential. Some numbers, we have about 150 institutions, that means companies or also institutes at universities or not in universities, scientific institutes. In Austria, we have a turnover in the space industry of about 180 million euro per year, and there are 1,000 people employed in the, well, somehow with space. That's not Earth observation, that's space. And you see a heat map, and there is Innsbruck on the left side a bit. And here it's mainly Earth observation. We have ENVIO, we have GeoVil, we have a few others there. So this hotspot here, that's an Earth observation hotspot here in Innsbruck. Of course, we are doing not everything out of the blue, so we have some guidance. There is a space strategy in Austria. It's called People, Climate and Economy. Space is for everyone. And if you can see the main goals, there are 6 main objectives of the strategy. Then you can really see that it's very broad on the one side, and you can also see that Earth observation is an integral part of this strategy. If you have some fantasy, I think you can think that Earth observation fits mainly to every of these goals. We had already a space agency. This is a renewed one, and the point number 5 and 6 is quite new, and we will do some more in the coming years on talents and diversity for space, and also we want to introduce a space dialogue with the population. So that means really that space should really, everyone should be aware that space is important. Okay, Josef was there. I don't have to tell so much on him. When I handed in this presentation on Thursday, I was not aware that he will be there this morning. But ESA, as I said, is not only important for us because there is an Austrian Director General currently. It helps us a lot with our priorities, with our priorities of the industry, scientific priorities and political priorities. The good thing with ESA is that, of course, you have to pay. Every country for something has any way to pay, for example, for the spaceport in South America, in Kourou. But there are a lot of optional programs, and you, as a country, you can really find your own profile according to your priorities, to your strategies you have. And here you can see the Austrian profile. In red, the red columns, that's a share of these different sectors in the ESA budget. And blue is a share for each of these topics in the Austrian subscription. In this case, for the ministerial 2019, when money was collected by ESA from the member states, it's 2019. There was another one in 2022, but the ratio is more or less the same. So that means that there's much interest in Austrian technology development. If you go from the right to the left, there's much interest in contributing to telecommunication programs, and there is much interest also in Earth observation, where Austria contributes over proportionally. And there are many optional programs in Earth observation. I just picked out one, which is especially important for Austria, and also Josef Aschbacher mentioned it already, and later on Anna Maria will go into details still in the morning. It's a climate change initiative. Now there is a follow-up which is called Climate Space. And as I said, Austria's really contributing overproportionally in this program. The goal of this initiative is to create and offer time series for so-called essential climate variables. And what it is exactly, Anna Maria will tell you later on in detail. But you can see Austrian actors are involved in some of these essential climate variable projects, and it leads 3 of them. There is snow, Envios leading that. There is soil moisture, that's the Technical University of Vienna. There's permafrost, where the scientific lead is also with a small company, BGEOS, in Lower Austria. And there is one very important thing also, it says that 4 of these ECVs were transferred to Copernicus, to the Climate Change Service, and also Copernicus is, if you talk about Austrian space, a very important program, not only, again, when supplying the Sentinel satellites with these thermal insulation foils, but especially more downstream in the service part. And here I also just mentioned 3 services. Here in the land monitoring service, many of the pan-European information products are not coming only from Austria, but there is a significant Austrian participation in the consortia. It's the same for the climate change service. I just mentioned the ECVs, the essential climate variable products, and also at the emergency management service, the global flood monitoring is also coordinated in Austria. There's also a midstream part, so that's the Earth Observation Data Center, which was funded 10 years ago, which for the first time offered ground segment capacities in Austria, meaning that data coming from the satellites were archived, were distributed, were processed here in Austria also. I just mentioned in the beginning on our national program, the Austrian Space Applications Program. It's maybe a bit misleading, the title, because it's for the entire space sector. It's also for space technology, space science. And it's a very stable funding program. For a small country, we could be proud to have it, I have to say. You see the numbers, and you see on the right side, there's a lot of follow-up activities. Someone counted this year, what happened there over the last 20 years. And if you go to Earth observation, we see 2 trends in recent years. The first one is that the share of Earth observation downstream projects is growing significantly. The moment almost half of all the proposals we get are related to Earth observation. That's really amazing, I have to say. And the second trend is that in the last years, the focus of the program shifted a bit from the buildup of capacities and expertise, which was important 15 years ago, 10 years ago, to be successful in Copernicus, for example, which worked quite well. And now it's more about the user uptake, just to involve users on all levels to use Copernicus and the data and products of it. I picked out one project, yes. We just have, it's a so-called lighthouse project. That means it's a bigger project than usual, and it's about to support the national greenhouse gas inventory, and there are 2 foci on that. The first one is to find a new method to calculate how land use changes are affecting the greenhouse gas balance for Austria. And the second one is to build up capacities for inverse modeling of greenhouse gas fluxes. And this is already in preparation of one of the next sentinels in the Copernicus program, the CO2M. That will be a sentinel which is able to measure greenhouse gas concentration, mainly CO2, with a quite high spatial resolution. now I come to the end. So I think this is a nice bridge now to this course. We are also organizing since many, many years, since decades, I could say, a summer school every year on space. It's in Alpbach, it's also in Tyrol. It's not so far away from the place where you will be on Wednesday evening for the dinner. And on this summer school, it's every July, every year. There are about 50 to 60 students from engineering and science for 10 days. And basically they learn how to make a concept for a mission, for a space mission, for a satellite, for instruments. And this year it was not Earth observation, but it was about giant planets and their moons. And in the first version of this title, I think it was giant planets and their icy moons. So there's another connection maybe. And with this, I want to close my presentation. Just wishing you a very good week, very fruitful discussions here, and well, a very nice, and much fun, of course. So it should be fun, first of all, and then I think you learn quite easy. So that's it from my side. Thank you very much.
Okay, so I will say a few words about our EU Science for Society program. Inside this program, we are doing several activities related to snow and glaciers. After me, we'll hear from Anna Maria, who's working in another part of ESA. We are in the same department, but we are in different divisions. So also working on snow and glacier, but from a bit different perspective. So I'll be rather brief because I had promised 20 minutes to Anna Maria. Now on the agenda there is only 15, so I will try to be brief. So in my section, so it's called the science section within our Green Solutions divisions. We are working on different areas, all with the objective to push science forward. So one thing we are doing is to try to engage with the community, and we do that in different ways. But a main way is to organize workshops that we are doing either that ESA is organizing it alone, inviting the scientific community, or we are partnering with the scientific organizations. That's one activity. We are also doing a lot of training and education activities, like what we are doing here today, doing that in different thematics and on different levels. We are also doing more basic training courses than this one. Then we are working a lot. That's our main core activity is more on these two here. So first of all, to develop new methods and new observation products, so based on Earth observation, that can be useful for the scientific community, but also for more operational communities. And then we also often in our activities, we try to use these products already to test it together with the science community and also test with some operational users. We also are involved in scientific campaigns so that we can also get other types of data, so not only satellite data, but for example, airborne data or in situ data that we can either complement the satellite data to get better products or to calibrate the methods or to validate them. We are also developing a number of open science tools and virtual labs, and one of the tools that we put quite some effort into is SNAP, for processing and analyzing Sentinel data and some other data. So, and that you will both see and you will see it in practice, and we'll use it in practice during the course. Networking and partnerships. We are trying to, so we do a lot of projects related to these new methods and advancing Earth system science. So one project will work on some aspect of, for example, snow. Another project will work on another aspect. And what we're trying to do as an effort of networking and partnerships is we are defining what we call science clusters. So we try to make different projects work together so we can have some more ambitious goals that we can reach by putting all these different projects together. And we do it between ESA projects, but also together with projects financed by the European Commission. And then from all these activities, we learn some things during the projects, and in the end, that can be useful for providing input to our new missions. So in my section, we are not developing new missions. That's other sections of division taking care of that. But we provide our inputs from what we learn during this activity. So that's in a nutshell what we are doing in my section. We are working a lot on the water cycle, which is a complex thing. And so just to put that in context, that's one of our kind of priority areas, both ourselves and in our collaboration with the Commission. So of course in the water cycle, the glaciers and the snow is key. So we have several projects on these issues, and I just wanted to mention two of them. So first of all, the Alp Snow projects, led by Thomas Nagler here. The goal of these projects was really to develop new methods and products for monitoring physical parameters for the seasonal snow in the Alps in particular, because monitoring with remote sensing in mountainous terrain is much more difficult than in flat terrain. And just maybe to say one thing about how are these projects coming to be born? And that's the work of me and my colleagues, that main activity for us is to try to define new projects. So we learn from the scientific community what should be scientific as issues to be addressed. And then we try to define a project. We say what should be output of the project and a few things to be done. And then we send out an invitation to the scientific community and also to industry. And then we get back proposals. So we launched, for example, this Alp Snow. We sent out an invitation, and we got several proposals. And the best one was the one that was led by NVO here. So, and that's in this way, mainly, that we are working, that we are defining the project, we are inviting industry and the research community to do these activities, and we get nice projects as a result. So here, for example, in these Alp Snow projects, products that were developed further and experimented was, for example, snow area extent, which is more. So we had more operational products coming out. Snow surface albedo and grain size also using Sentinel-3, more operational product. Snow melt area extent also using, for example, Sentinel-1, and melt phase more as an experimental exercise. Snow water equivalent, we can do it operationally, but using more the modeling. As a product more directly from Earth observation is still it's experimental, and same for snowbed. So what we tried in this project was both to develop such product and also then to test out some scientific and operational applications. Another project is the AI for snow, and here we are looking at fractional snow cover. And the particular thing we are looking at in this project is that we can have with the medium, we call them medium resolution satellites like MODIS and Sentinel-3. So when we When we have data between 300 meters and 500 meters, you can get them at daily if there are no clouds. But you have high resolution data like Sentinel-2 and Landsat, so 10 and 30 meters, but where we get images, if you're lucky with the Sentinel-2, for example, but it's every 5 days. So if we need a daily product, and we want better resolution than the 3 and 5 meter, we must find a nice way, and that's what is being experimented with in this project, using a neural network in order to provide a 100-meter product daily of the fractional snow cover. So these are just 2 examples of this one. We had also a project devoted to glacier that we just closed also, but I won't go into details about that here today. And then just mention as one of these workshops that we are doing. We had a huge event in Copenhagen last week. It's maybe a bit more than a week now, but that was the European Polar Science Week that brought together really the big community of polar scientists. So many of them, most of them are not remote sensing specialists, but many also, and trying to bring all these people together and showcase what is the state of the art and try to advance. So this is how we are working with to really try to engage with the scientific community. Then some opportunities for young scientists, and not only for the young scientists, by the way. We have established now in ESA, in Esrin, the center where I'm working, in Frascati, close to Rome, what we call the Earth System Science Hub. And in this hub, we are having people coming can be postdocs coming for 2 years, or we have senior scientists coming for shorter periods, like 3 months or maybe up to a year. And with the goal of working on issues that are of interest to us, and also take part in these activities that we are doing of more of coordination. I mentioned this science cluster where we make projects work together, etc. So we are launching now and then a call, so for vacancy notice, so for free jobs to come, free postdoc opportunities in the science lab. So that you can come there and work together with the other people in the science hub. There will not be so many colleagues working on the same thematics as you, because it's not a huge lab, but for the moment we have approximately 16 people, but I think it will increase further. And so that's one opportunity to look out for when we recruit more people to come and join the science hub. And then we have also this Living Planet Fellowship. That's also postdocs. We are not funding them 100%, but we are funding partial funding of it. And what we require is that you work on a subject that is of interest to us, and then we fund it partly. And you can do it in any institution, at least in Europe. And you are also welcome to come and do part of the postdoc inside ESA, but it's not the entire thing. It's to have a part of it. So these are just a couple of opportunities that you can enjoy, or you can try, and you can find information on this on our website, which is this one, eoforsociety.esa.int, where we show both these new opportunities, what are going on as workshop, training courses, and you can find information about all our projects. So that was it. I hope I was quick and I leave enough time for you, Anna Maria. That one is also.
The mouse con.
Right, good morning everyone. My name is Anne-Maria Trufaya, and I work for the European Space Agency in the UK. In fact, I work for the office that Joseph mentioned earlier. We used to be called the Climate Office. There was a bit of reorganization, so we're actually a different section at the moment. But call us the Climate Office, please. One of the, the program that we run out of the Climate Office is the so-called ESA Climate Change Initiative program, which Thomas Geist mentioned earlier, which is all about developing long-term consistent data records. And I am actually a cryosphere scientist, and I'm in charge of all of the cryosphere-related projects that we run within the ESA CCI, which includes ice sheets and sea ice. But today I'm going to just highlight the glaciers and the snow CCI projects. And I've called this from R&D to operational services because ESA is a R&D agency, but ultimately we want to produce these data records for operational services. So this week you'll learn all about the theory of remote sensing of snow and ice, and then you'll learn in practical examples how to relate this theory to practical examples, but I'm going to set all of this in the context of long-term monitoring. So I think it's pretty obvious that we need to monitor our planet on a regular basis, systematically from space. So Thomas Nagler's laughing, but it really is a bit like, you can't just show up to the doctor once, you have to go often to be able to understand what's going on. And we need to understand the state of our climate, of our planet, to be able to better predict what's going to happen in the future, and to be able to make the appropriate evidence-based decisions. And this was really at the heart of the UNFCCC back in the 1990s, when they sort of realized that we needed to monitor our planet on a systematical level, that we needed systematic observations, not just from space, but in general. So it was the UNFCCC that instigated the Global Climate Observing System, GCOS, who are an entity under WMO, and they were tasked to identify the variables that we need to monitor our planet regularly, the variables that we need to better understand the characterization of our climate system. So GCOS identified these variables back already in the 1990s, but it wasn't really until 2007 at the Bali conference that the space agencies realized they weren't really doing quite enough to support this effort, because what was needed were these long-term, consistent, unbiased data sets, and these didn't exist up to then. So it was actually ESA that took the initiative in 2009 to start up this program, the Climate Change Initiative program, which was all about developing these data sets. And we've been really successful with this program, and we are currently in its extension phase. And in the last ministerial, we also received a lot of subscription for the next climate program, the Climate Space program, which Thomas also mentioned earlier. And of course, we're really, really pleased that Austria is one of our main contributors, because we have so much expertise in Austria that's really relevant. And even though Austria is only a small country, it really, really contributes a lot towards this program. So, again, the idea of the Climate Change Initiative was to dig deep into the archives, to take advantage of all the Earth observation data that we had, so that's ESA missions, but it's also other missions, and to generate these long-term climate data records, because of course we've now had satellites in space for more than 40 years. We actually should be able to produce these unbiased data sets. And of course the whole idea was to do this as a contribution to the ECV database that was requested by the UNFCCC. And we used the GCOS requirements as the real requirements to develop these data sets. And these are the 55 essential climate variables that were identified by GCOS, and we actually believe that 36 of these can benefit from space. That's directly or indirectly. So, for instance, projects like, or ECVs like permafrost. Permafrost is a subsurface phenomenon. You can't monitor it from space, but you can use space data to be able to say something about the ground thermal regime. So, for instance, in the permafrost project, they use snow water equivalent data, and they use land surface temperature data, and they put this into a model, and they can then calculate the ground temperatures. So the cryosphere ECVs here and that we have in the ESA Climate Change Initiative are, of course, the ice sheets. We have a project both on Greenland and on Antarctica. Then snow, which is led by Envio here in Innsbruck. We do have a permafrost project as well, which is led by BGEOS in Lower Austria. And we have the Glaciers project, which is led by University of Zurich, and Frank Paul is here as well this week, and we'll let you know all about how we monitor glaciers from space. The other cryosphere project that I am part of, but of course it's not a land cryosphere, is sea ice, and that one is based in Norway. So just a few highlights from CCI Glaciers. I'm not going to talk too much about it because Frank will tell you all about this and can do this in much more detail than I am. But basically what we monitor in terms of glaciers is glacier extent. We monitor surface elevation changes, and we monitor ice velocities. We have two focus areas at the moment, which are in the high Arctic islands, as well as the high mountain Asia. We also look at snow and glacier phases, and I just highlighted here, we recently developed a global inventory of glacier surges for a specific time period, so 2017-2022. And we did this from Sentinel-1 radar backscatter, and it's quite an interesting new development that we had within the ESA Glaciers project. In terms of snow, the CCI Snow project set out to develop in its baseline project a global homogeneous time series of snow cover fraction, as well as of snow water equivalent. And we did this at first with just only observations, but we are also now developing a cloud gap-filled product, depending on application. This is the important part of the CCI is we don't just take the GCOS requirements, we also have to interact with the users, and it depends on user what type of product you want. So I think that's also one of the things you always have to be aware of. If you will use these data products, what is your specific application, and is it appropriate for what you need? So this is just, the snow extent product, the snow cover fraction product. And as you can see, we used MODIS data and ATSR data. And we actually see from this long time series that there's quite an high interannual variability in the snow cover area. So this is just animation of the cloud gap filled snow extent product. And this is research that we're doing, so we don't want to just interpolate between where the clouds are. We want to actually make sure that what it says in the gaps, it makes sense. So this is why it's ongoing R&D on how to assimilate a results from a snowpack model into this data set. And then this is the other product that we do within the ESA CCI baseline project for snow, which is snow water equivalent, which tells us something about snow mass. This is only for the Northern Hemisphere because this is from passive microwave data set, and we don't really have very much snow in the Southern Hemisphere to cover this. It's mostly only in mountains, and this product is actually not in mountain areas, and you'll learn all about the difficulties of monitoring snow in mountains, which is actually where we want to monitor it. But there are very many difficulties in doing this, and a lot of research that still has to go into monitoring snow in mountain areas from space. And then this is quite an interesting new product that we have developed, or I say we, but of course it's NVO, have developed, which is on wet snow and a melt extent in mountain areas from synthetic aperture radar. And in fact, I saw in the program that Thomas is going to talk about this on Friday morning, so you'll have to stay awake until then. And it's a really exciting new product that I think will actually be quite interesting for you to find out about how it works. So I think it's probably obvious that satellite observations are crucial to better understanding our climate system, and in fact, it was highlighted in the latest IPCC AR6 report that satellite measurement techniques are now long enough to be relevant for climate assessment. And we are really actually quite proud at the Climate Office that the CCI has contributed a lot to the IPCC reports. And in fact, you can see how our contributions have increased. Of course, contributions about space have increased in general, but the CCI has really been a success story, and we're really, really pleased that we will be continuing with this type of work in the future under our new climate program, Climate Space, because research and development into these long time series is absolutely crucial and has to continue. So this is where I actually only have one slide on the Copernicus services because I'm not from Copernicus, but as I said, ESA is an R&D agency. We're all about doing the research and development. But what we really want is that these data sets, these climate data records, are generated operationally. So we are very lucky that in the beginning of when the Copernicus Climate Change Service, C3S, established itself, we sort of got in touch with them and talked to them about what we were doing. And we actually have an agreement between CCI and C3S. Doesn't mean that all our R&D gets transferred automatically, not at all. They still have their own calls. But it was quite clear from the beginning that the work that we did within the ESA CCI was so quality assured with all the documentation that we had that it was quite easy to broker between our projects and the Copernicus services. So yeah, I think these are the latest numbers, in fact, that we now have 18 of our own ECV projects that have been transferred to the Copernicus services. And I think it's not C3S, I put C3S here, but there were some changes within Copernicus who was now in charge of what, but in general of the Copernicus services. So, yeah, we rightly are very proud, and we think this should be continued in the future. I hope that all of you will learn a little bit something this week, and maybe in the future you will also be able to join some of these consortia working on snow and ice, because it's really, really important work that has to be done and has to continue. And I'm very pleased that I'm here this week, and if you have any more questions about how we monitor, how we do these long-term observations from space, and also what opportunities there are in the future, then you're very welcome to come up to me and talk to me. So that's it for me today.